Hello, boys and girls. It's Mrs. Lane here, and today we are discussing using mean absolute deviation, or using MAD. You will be on pages 310 and 311 if you have the 2020 version. And if you have the 2017 version of the book, you're going to be on pages 300 and 301. So we're going to start with the question in tan. Consider another way to describe the Death Valley National Park temperature data. Calculate the mean absolute deviation, or MAD. What does the MAD tell you about the variability of the temperatures? So here we go back to our original 15 temperatures. And then what they've done with those temperatures is they knew that the mean was 89.3. That number is going to be very important to us. So they take each temperature point, 99. How far is 99 away from 89.3? Well, it's 9.7 degrees higher. How far is 88 away from 89.3? Well, 88 is 1.3 degrees lower. How far is 71 from 89.3? Well, 71 is 18 3/10 lower. So you can see all they're doing is figuring out how far each of these points is from the mean. And if it's a point above the mean, it's just the number. If it's a point that's below the mean, it gets a negative number. And then once they've got that whole column figured out, they can convert it to absolute deviation, or as we would think of it, absolute value. The absolute value of 9.7 is 9.7. The absolute value of negative 1.3 is 1.3. The absolute value of negative 18.3 is 18.3. So that's what they've done. And then they've added up all of that absolute deviation, and they came up with 119 3/10, and they divided it by 15. Does anyone know why they divided it by 15? Well, they divided it by 15 because there were 15 numbers to begin with. And what they came up with is a MAD score of 7 95/100. So what that means is, on average, each of these data points is 7 95/100 away, almost 8 points away from the mean. Okay, let's move over to page 301 or 311, depending on your book, and answer the questions. All right, boys and girls, we're going to start with number 7. And number 7 asks us, what does the MAD mean within this context? So if we go back and look at our chart, our MAD was 7 95/100. That means, on average, the temperatures vary 7 95/100 degrees away from the mean. On average. Oops. The temps vary 7 95/100, almost at 8. We're knocking on the door of 8 degrees from the mean. Okay, I hope you wrote that down. Do you guys remember what the mean was? Yep, just look at your chart. The mean is 89.3. Okay, let's take a look at number 8. Given this context, does the MAD value indicate a higher or lower variability? So basically what we're saying is our MAD score is 7.95 degrees. Now, let's think of that. 7.95 degrees. It's almost 8 degrees. Would you say that 8 degrees on average, that big of a deviation is high or low? My answer is that I'm thinking we only have 15 temperatures. And with 15 temperatures recorded, an average deviation of 8 degrees from the mean is going to be pretty high. That's pretty high. It's a pretty large temperature difference. Okay, so let's write that down. With 15 temperatures, And again, you can just abbreviate it as temps. With 15 temps recorded, an average deviation of 8 degrees, from the mean is pretty high variability. All right, let's move on to the next one. The next one is asking question number 9. If you replace the outlier of 113 with 100, what happens to the MAD? Okay, so essentially what they're asking us, here's our MAD score. Here's 113. Okay, so if we take out this 113 and we put 100 there. Okay, so is that going to change this number? Well, of course it is. It's going to be 1, because how close now is 100 to 89.3? Well, if you have 100 and you subtract 89.3, let's just do it. Many of you could figure this out in your head, but we're going to do it this way. So 0, and we've got, that becomes a 9, that becomes a 9, and this becomes 10. 10 minus 3 is 7. 9 minus 9 is 0. And 9 minus 8 is 1. And we bring over our decimal. So that 23.7 becomes 10.7. Is this going to mess up by putting 10.7 in the place of this 23.7? Is that going to change my overall number? Well, absolutely it is. And is it going to make this number here higher or lower? It's going to make it lower, right? So definitely we're going to come up with a different MAD score. So your MAD score will decrease. Why does the MAD score decrease? Because the sum of the absolute distance from the mean decreases. All right, get that written down. Read over it again to make sure it makes sense to you. And we'll go on to the next one. Question number 10. Within this context, how are the mean and the MAD different? How are they related? So first of all, what is the mean? The mean is the middle number, so let's write that down. It's the measure of the center. The mean is the middle number, the measure of the center. Okay. Okay. And the mean tells us if we just put all these data points in a bag, all these temperatures in a bag and shook them up and they all got mixed up so they were equal, all 15 of them would be at 89.3 because so that's our average. Okay. The MAD, what is the MAD? The MAD is the measure of variability. That's a hard word to say, variability. The MAD is the measure of variability. It measures how far each data point is from the mean. All right, ladies and gents, go ahead and do number 11 on your own to try it, and then you can do your PPS pages. Remember, if you have any questions or any concerns about your math or about any of your subjects, you can always give me a text or an email or a phone call. All right, thanks, 6th grade. See you later.